Hi everyone. Your question is design NFA to accept all strings where each string should contain ABB as a substring. Based on the condition, try to write down minimum length string. Here first minimum length string is ABB itself because this is the minimum length string which satisfying the condition, it contains ABB. If I want to write another string, string should contain ABB, but before that any symbol is possible, like single A may come, but after that ABB is coming. Double A may come before reading the ABB, triple A may come before reading the ABB, or no A's may come, for example epsilon, but after that ABB is coming. After reading ABB, single A may come. After reading ABB, double A may come. After reading ABB, triple A may come, or no A's are also possible like epsilon. What I mean to explain here, string should contain ABB. Before that and after it, any symbol is possible, maybe A or maybe B. Once we understand the condition, try to write down the automata. Q0 is our starting state. First string is ABB. ABB should get accepted. One state, one symbol at a time. Q0 reading the first symbol A. It's going to the next state, Q1. Single A should not get accepted, hence Q1 is a non-final. Next symbol is B. Q1 reading B. So it's going to the next state, Q2. AB should not get accepted, hence Q2 is a non-final. Next symbol is B. And this is the last symbol. We are designing automata for ABB as a substring. When we are writing transition for B from the Q2, our string will get completed and ABB should get accepted. It means what? By reading ABB, automata should go to the final state. Hence, I am making this Q3 as a final state. As this is the last transition, this is the last symbol of the ABB. Hence, Q3 is a final state. Here we design automata for our main condition ABB should be substring and ABB is getting accepted at Q3. Post designing the automata for the condition, check whether are we trying to design automata for NFA or DFA. Here it's a given NFA, non-deterministic. It means what? There may be or may not be any transition for the given symbols of the sigma. Like here there may be one transition for the A or zero transition for A, maybe one transition for B or zero transition for B, or multiple transition for A and B. That's the meaning of non-deterministic. But along with this, another all required string should get satisfied. Like here ABB is present, but the string is what? A, then ABB, then A. Likewise, all strings should get satisfied. If you observe here, as I explained, string should contain ABB, but before that, any A's are possible. Before that means what? Before reading ABB means what? At state Q0, I am writing here state Q0. Before reading ABB, because Q0 starting reading ABB. Before reading that, zero number of A's are possible means what? Epsilon. Single A is possible. Why? Because once we read the single A, after that ABB is coming. Yeah, it contains ABB. This is a valid string. Double A is also possible. Triple A is also possible. So all are valid string because after reading all these A's, it contains ABB. So Q0 is a state which is reading zero number of A's or one number of A or many number of A's. Hence scenario is what? Zero or many A's. Zero or many means what? Self loop. At which state? State is Q0. For which symbol? Symbol is A. So I am writing here self loop for A. Similarly, it may possible that before reading ABB, any symbol like here sigma contains A comma B. So B also possible. Before reading ABB, single B may come, double B may come, triple B may come, or no B's like epsilon. So before reading ABB, any symbol is possible like zero number of B's, one B or many B's. So scenario is of zero or many. For which symbol? B. At which state? Q0. So at Q0 we have the self loop for A. Similarly we have the self loop for B. Conceptually, before reading ABB, any symbol is possible. It may be A or it may be B. Now, if suppose after reading the ABB, once we complete reading the ABB, where will be the automata? By reading A, by reading B, and one more B, automata reaching to Q3. So after reading ABB, how to reach to final state? By reading ABB. Once we read the ABB, we may have single A or we may have single B at Q3. I am repeating the same scenario here also. Parallelly I am explaining you. Once I read the ABB, single A possible, double A also possible. Once I read the ABB, single B is possible, double B also possible, triple A is possible, triple B is possible. Or I can say once I read the ABB, no A's are possible, means what? Epsilon. Once I read the ABB, no B's are possible, means what? Epsilon. Epsilon is an empty string. It does not contain neither A nor B. It means what? Once I read the ABB at state Q3, 0 number of A's are possible, or 1 or 2 or 100. Similarly at Q3, 0 number of B's are possible. Epsilon means empty string, or 1B or 2B or many B's. It means what? At Q3, chances of getting 0 number of A's or 0 number of B's, or many number of A's or many number of B's. So at Q3, chances of getting 0 or many scenario for which symbol? For A as well as for B. And as I explained in all previous videos, whenever in TOC there is a scenario of 0 or many, you need to give the self loop. At state Q3, I explained it for the Q3. For which symbol? Symbol is A as well as symbol is B. So here self loop for A as well as for B. Now what is this conceptually? If you observe this diagram conceptually, our question is to design NFA. For what? For accepting all the string which contains ABB as a substring. If you observe this, our main focus is on the ABB. But before that, I have explained here in this while writing the MLS. Before ABB, any A's may come. Or I can say before ABB, many B's may come. After ABB, many A's may come, or many B's may come, or it may not come, means what? Epsilon. Epsilon means what? 0 number of symbol. So here scenario is what? 0 or many A's before ABB. Before ABB means what? At Q0, 0 or number of F's, or before ABB, 0 or many B's. That's the reason at Q0 I have given self loop for A or B. Similarly, once I read the ABB, after that 0 B's may possible, 1 B or many B's are possible. Similarly here, after reading ABB, 0 or many A's are possible. 0 or many means what? Self loop. That's the reason I have given here self loop for A or B. And this becomes our final NFA to accept all the strings where string contains ABB as a substring. Similarly, you can practice to design NFA where string contains 100 as a substring. Thank you for watching.